in this video we are going to talk about operators. Now, exactly what operators are, that operators actually used to do some calculations. Okay, in programming languages there are many kinds of operators. Okay, in your basic mathematics in your school days you have heard about like a plus b. There are some algebraic forms. So here the plus is the operator actually, and what the a and b are, these are called operands. These are called actually operands, and this plus is called operator. Okay, so operators are used to do some calculations between the operands to yield a value. Okay, so in C there are many types of operators. Okay, the first one is arithmetic operator. The another one is assignment operator. Another one is relational operator. Then logical operator. Then bitwise operator. Then shifting operator. Then we can say like Sizeof operator. Then we can talk about conditional operator. Then we can talk about increment and decrement operator. So these are the 9 basic types of operators, okay, in C language. We will go through them one by one. The first one which we are going to start is arithmetic operator. So the first one is arithmetic operator. Now there are 2 types of arithmetic operator. First one is unary, another one is binary. The first one is unary arithmetic operator. Second one is binary arithmetic operator. The unary or arithmetic operators are like plus and minus. This is called unary plus, this is called unary minus. Now what is unary plus and unary minus actually is? For example, if I write like x plus minus y, okay, so here this is called the unary minus. Why? Because the number of operand is 1, as the operator is with only one operand, that's why it is called unary operator. Okay, now if I write x minus plus y, for example, we do not use to write that plus y, but if we use, then it would be called as unary plus. Okay, so that's why the unary operator is a noun. Now let's talk about the binary arithmetic operator. So there are 5 binary arithmetic operators: plus, minus, asterisk, divide, and modulus. Let's talk about them. First one is plus, this is minus, this is asterisk, this is divide, and this is percent symbol, which is modulus. Now this is called addition operation. This is for subtraction. This is for multiplication. This is for division, and this is for modulus. Okay, now exactly modulus means what? Okay, so we are going to discuss them one by one. If I take int a equal to 10 and int b equal to, for example, 5. Now if I write here c equal to a plus b, okay, and if I write integer d equal to a minus b, then if I write integer equal to a asterisk b, then if I write integer equal to a divided by b, then if I write integer equal to a modulus b. Now here a plus b, that means 10 plus 15, 10 plus 5, which is 15, then c equal to will be 15. A minus B, that means 10 minus 5, which is 5. Then D equal to will be equal to 5 equal to A asterisk B, then 10 into 5, which is 50, then E equal to 50, and then D equal to A divided by B, obviously D equal to 2, and A modulus 5, then E equal to 0. So now what is modulus? Modulus is the remainder of the division operation between A and B. So 10 remainder to 5, which is 0. That's why A equal to 0. Now let's take another example where A equal to 13 and B equal to 5. Now here all the operations would be same obviously, but I would like to emphasize on the division operation and the modulus operation. Okay, now here if I write A, well, if I write equal to A divided by B, now what will be the answer? The answer will be 2. Why 2? Because this division operation actually called integer division. What it is called? Integer division. Now bhaiya, what is this? What is integer division? Integer division actually like 13 divided by 5. Kitna aayega? 5 into 2 equal to 10. The remainder is 3. So the integer division means this quotient part only, not the remainder one. Okay, we will take this part only, like 13 divided by 5, which is 2 point then 30, then I guess 2.6, I guess, if I am not wrong. So we will eliminate, okay, we'll eliminate this part. We will take the integer part, which is the before the dot symbol. We will take that part only. That is called integer division in C. Okay, now how we will get the 2.5 answer, that is another question. We will be discussing them in later the typecasting video. Okay, and also we will have a lot of example there also, so don't worry. Okay, right now you just have to remind that division means the integer division, and 13 divided by 5, which is equal to 2. Okay, now let's have another one, like D equal to A modulus 5. Sorry, D equal to A modulus B. So now 13 divided by 5 will have the remainder 3. Okay? So D will be equal to 3. So this is the thing. This is the way how arithmetic operator actually works. Cool. Now let's go to laptop and check either everything working correctly or not. So hash include stdio dot h int main integer A equal to 13 and B equal to 5. Okay, so those who don't know, this is called initialization of variables, second variables. Okay, now if I write printf, okay, %d plus %d to %d backslash comma a comma a plus b. Okay, now I am pressing shift alter and the down arrow button to copy 1 2 3 4. Okay, and then return 0. Now here what we are going to do, we are going to make some changes, like here it would be minus, here it would be minus, here and here it would be asterisk, here it would be divide, and here it would be modulus. So here we have written all the things, and now we are going to run. So here there is, you can see that there is an error in the output screen where it is 13% D it is printing out, because we can't print a person sign here by putting one single person sign. Okay, that's why we need to put another one. Okay, this is also another escape sequence. Okay, so the compiler will be understanding that he has to print it has to print one person sign here. Okay, now let's run it. So here you can see that 13 plus 5 equal to 18, 13 minus 5 equal to 8, then 13 into 5 equal to 65, 13 divided by 5 equal to 2, and 13 modulus 5 equal to 3. So in this way actually arithmetic operators actually work. Okay, and if you want to take some input, that is another issue. Okay, so this is the thing, this is the arithmetic operation. So now let's talk about the assignment operator. Okay, now what assignment operator is actually, basically a equal to sign is the assignment operator in C, not in C, in most of the programming languages. So what exactly assignment is? Okay, now if I take an example, you would very easily you will understand what exactly assignment is. In basic algebra you have found x equal to 5, isn't it? That means the value 5 has been assigned to x. X is carrying out the value 5 in the entire problem or the thing like that, isn't it? In the same way, in C programming also, 5 is getting assigned to x. That means x equal to 5. Now the question is, okay, how we would define and how would we execute all these things? So before starting with the assignment operator, you need to understand that how can we write and what can be assigned and where it can be assigned. Okay, now here there is an equal sign. The left side will be called as left hand side and the right side will be called as right hand side. Okay, now the left hand side must be a variable of any data type, that doesn't matter, but it must be a variable. Okay, but in case of right hand side, it can be a constant, it can be a variable itself, or it can be an expression. There can be twice. Let's take some example and try to understand how the things will happen. For example, here if I write integer a equal to 5, okay, and if I write integer b equal to 10, so these are the assignments. Like here this is variable which we have talked about here, variable, this is fixed, and here this is a constant. Okay, but when I write integer x equal to a, now we know that the a is having value 5. Now integer x equal to, this is another assignment. Here this is a variable and this is also another variable. Okay, so this condition satisfied, this also satisfied. Okay, so these two can be done. Now let's talk about the, let's give an example of expression. Now if I write that integer c equal to a plus b asterisk x, for example, so here this is an expression and this is a variable, so the value of the expression will be calculated and that value will be assigned to this variable. Clear? So these are the three types of right hand side things which can be assigned to a variable. Clear? Now let's take an example. Integer a equal to 5, integer b equal to 10. So here we can assign some values. Now what we need to do, what is the application of assignment operator? If I say that there are basically two basic problems which would be very much clear to you if you or try to understand this, that how to swap them. Okay, swap variables would be the would be an example of the application of assignment operator. So here there are two ways. Okay, here there are two ways with using third variable. That means here we are going to use a third variable to swap these two values. Now let me explain it. Okay, here there is a jar of having some rice. Okay, and here there is another jar of having some dal. Okay, here there are some rice, here there are some dal. Now we need to swap them. That means we need to put this rice into this green jar and we need to put this dal into this blue jar. Okay, how do we do that? Basic common sense. We would be having another jar, we would be copying it, and then we would be copying it to here, and then we would be pouring here to here. That means this is the first operation, this is the second operation, and here this is the third operation. In the first operation, we would be putting this rice into this jar, and then we would be putting this dal into this jar, and then we would be putting this rice into this green jar. Okay, so this is the way. In the same way, if I use this like a equal to 10, b equal to 20. Okay, now if I put integer c equal to a, because c, this is c, this is a, and this is b. So a is a, the value of a will be copied to c, that means c equal to a, then a equal to b, and then b equal to c, that means this to this. Okay, so this is the basic way to swap to variables, but I do not want to use any third variable. So what will be the algorithm? That's a basic important question, obviously. Now a equal to 10, b equal to 20, for example. So if I do not want to take the third variable, then the algorithm would be like a equal to a plus b, then b equal to a minus b, and then a equal to a minus b. So this is the process. Now how the things are happening? So here a, and here it is b. Okay, now a is having 10, b is having 20. Now a equal to a plus b, that means a equal to what? 10 plus 20, which is 30. Then the a would be value 30. Okay, and now b equal to a minus b. Now b equal to a minus b, that means 30 minus 20, that means b equal to 10. So the value of b will be 10, and then a equal to a minus b. Now a equal to 30, b equal to 10, that means 30 minus 20, which is 30 minus 10, which is 20. So a is 20. So now after these three statements, you can see that a equal to 20, b equal to 10, whereas a was 20, a was 10, and b was 20. So now you can see that the values have been swapped. So in this way, we can use assignments operators to do some calculation, and here there are some basic application. Okay, this is with using third variable, and it is without using third variable. Please note them down properly, because this is going to be very important concepts which would be needed a lot of time in the practical comparative coding or practical problem solving skills. Okay, so these are the very important things, so you need to remember them, you need to note them down and try to understand properly. Do not need to remember blindly, try to just follow the tricks, try to grab the tricks and ideas so that you could implement it. Okay, so this is all about basics of assignment operators. But now there are some few more things which you need to know. Like if I say integer x comma y comma z, and if I implement x equal to y equal to z equal to 20, this is also a correct statement. Okay, this might be a question to you. Now how these things happen? Now the 20 will be assigned to z, and then the z will assign to y. That means the 20 is indirectly assigning to y, and then y would be assigning to x. That means the 20 is indirectly assigning to x. Okay, so the right to left, it is working, isn't it? This is another process. Now for example, this is x equal to 5, for example. Now if I write x equal to x plus 5, okay, so this is an expression where there it is a variable obviously, and this is an expression, but this expression is containing the variable x. Okay, x equal to x plus 5. This could be written like this: x plus equal to 5. So this is another this is another assignment operator, plus equal to. Similarly, we can use minus equal to, asterisk equal to, divide equal to, modulus equal to. There are many more. Okay, on the upcoming minutes we will be discussing about the bitwise operator, logical operator. That's also could be used like that. Okay, so don't worry, we will talk about them in the end of the section. definitely. So this is another thing, like if you want to write x equal to 12 and if you want to write x asterisk equal to 3, this means that x equal to x asterisk 3, x is value having 12, that means 12 into 3, which is 36. That's it. So in this way we can use some other assignment operators to implement and to code very efficiently. So this is all about assignments operator. Let's talk about the relational operator. Now relational operators are less than, equal to, greater than, equal to, equal, and not equal. This is less than, equal to, this is greater than, equal to, this is equal, and this is not equal. Now what relational operators are actually? Relational operators are used to define or to determine the relation between two variables or constants or expressions. Okay, for example, if I write a equal to 5 and b equal to 10, so if I write a greater than b, that means we are defining the relation between a and b. Now the question comes that what this expression will return. Okay, so it is returning 1 while being true, and this returns 0 while being false. For example, if I write for example a equal to 12 and b equal to 13. Okay, now what is going to do, what is a greater than b, a greater than equal to b, a less than b, a less equal to b, then a equal b, a not equal b. Okay, now this is going to return as 12 is greater than 13 is a false, that means 0, this is also 0, this is 1, this is 1, a equal b. This defines either the a and b are same or not. The left hand side, the right hand side are same or not. If they are same, then this is going to return 1. If they are not same, then it is going to return 0. Okay, so obviously it is going to return 0 because 12 is not equal to 13, we all know that, and here it is not equal to b. Okay, so this exclamatory sign and equal to are called not equal to. If they are not equal to each other, then this is going to return 1, else they are going to return 0. Now let's go to laptop and try to run the codes which I have talked about, and also we will have a demonstration, okay, on this relational operator. So here this is the code. I have taken the input of a and b, and after that I have printed out, and then after I have done the swap operation, and after that I have printed them out again. Okay, so that you could have a clear output. Okay, so let's run it. So enter two numbers. I have 14 and then 18. Okay, so before swapping, a equal to 14, b equal to 18, and after swapping it is a equal to 18 and b equal to 14. So yeah, now let us implement the other algorithm. A equal to a plus b, then b equal to a minus b, and then a equal to a minus b, sorry, equal to a minus b. Okay, and now let's try to run. Enter to number. It's 13 and 17. So you can see a equal to 13, b equal to 17, and then a equal to 17 and b equal to 13 here. Okay, ab, so both are same. Okay, so yeah, that's the thing. So now you can see that a greater than b is 0, a less than b obviously is 1 because 34 is less than 78, and greater than or equal to 0, less than or equal to 1, and a equal b is 0 because obviously definitely 34 is not equal to 78, and not equal to b is 1 because obviously it's not equal to 78. That's obviously clear now. So we are done with the relational operator. Now let's talk about the logical operator. So logical operator. So there are three logical operators, which is logical OR, logical AND, and logical NOT. Okay, so logical OR is represented by two vertical bars. Logical AND is to ampersand, and logical NOT is the exclamatory sign. So one by one we are going to discuss. First one is logical OR. So to understand the logical OR, you need to understand the logical AND gate. Okay, so this is the logical OR gate. A, B and Y equal to A or B. Okay, now if you don't know anything about logical OR gate, then try to understand, or you can try to Google. Okay, I am not going into deeper section right now. If you want me to make the videos on the digital electronics topic, gates and all and the circuits, so let me know in the comment section. I will definitely try to make the videos which would be relevant to the corporate software domain, which would be, those knowledge would be needed in the software industry, so I could make the videos as well, so don't worry. So let's try to make the truth table. 0 0 0 1 1 0 1 1. Okay, so here what will be the output? Output will be obviously 0 1 1 1. Now you need to understand this one thing, that when the this input is on or is 1, the output is 1. You can directly say, we do not need to check what exactly B is. Clear? But when we are having 0, we need to check this way. If B is 0, the output is 0. If B is 1, the output is 1. Clear? So this is the thing, this is the logic which we are going to implement here as well. Okay, so if A is 1, what exactly B is, it doesn't matter, Y is 1. And when A is 0, we are going to check either it is 0 or 1. Either it is 0, it is 0, either it is 1 or it is 1. The output is 1. This is logical OR gate. Okay, now what we are going to discuss here in logical OR operation. Okay, so this is the logical OR notation. Here there would be left hand side and there would be right hand side. Here it could be a constant or a variable or an expression. Here also it could be a constant, it could be a variable, or it could be an expression. Okay, so you need to understand what exactly true value, what exactly a false value is. If any constant is 0, okay, that means it is a false value. Either it is a non-zero, that means it could be minus infinity to minus 1, or it would be 1 to infinity. It could be any value, any. Either it is minus infinity to minus 1 is a close interval, obviously it would be including both of them, and 1 to infinity. Okay, I can modify this as well as open series. Okay, so this could be a true value. That means if I say it one line, that any non-zero value is a true value. That means if any constant is there which is a non-zero value, this is a true value. You can consider this part is true. Clear? Now if any variable, if I talk about variable, then obviously if a variable, for example integer x equal to 0, okay, and you have put this x before this logical OR, so obviously it is going to be false because 0 is a false value. So if it is a non-zero value, obviously it is going to be true value. Okay, then it would be true. And if any variable would be assigned as 0, okay, then it is going to be a false value. That's the basic thing. Okay, in the same thing for the expression also. For example, if I write x equal to 5, y equal to 6, okay, and if I write x plus 1 minus y, this is the expression, then logical OR, and this is another expression. So obviously this expression is going to return the value 0, because x plus 1 is 5 plus 6, that means minus 6, which is resulting 0. So obviously this is 0. So zero, as the expression is returning a zero value, that means it is false. If it is not returning any zero value, it is returning a non-zero value, now which could be anything. So obviously it is going to be true. Clear? Same thing would be in the right hand side also. Now, if any expression is going to return any true value here, we are not considering this. If it is considering returning any false value, then we would be considering this as the truth table. So now let's talk about the AND operator. So logical AND operator, as you all know, that we can write like this in C. And so how the AND operator is going to be used, how they really do work. So for that we need to understand about the AND gate truth table. So AND gate is this one, A, B, there are two inputs and this is Y equal to A and B. And if I talk about the truth table, then this is this one. So 0 0 0 1 1 0 1 1 0 0 0 1. So when the input of A is 0, we can directly say that the output is 0. But if it is 1, then we have to check for B, and if B is 0, output is 0, B is 1, output is 1. Clear? Now this kind of logic would be used when you will be solving problems in AND operator. Okay, for example, this is AND operator, and this is the left hand side and this is the right hand side. Clear? Now in the left hand side, if it is true, then we can go to the second expression. We have to check either it is false or true. If it is false, then obviously the output is 0. If it is true, then the output is 1. But if it is false, we do not need to go into this place. We can directly say that the output is 0. Okay, clear? Now let's talk about the logical NOT operation. Logical NOT. So logical NOT is basically nothing but the NOT gate. Obviously here it is A and this is A bar. That means if it is 0, this is 1. If it is 1, it is 0. That's it, nothing else. Okay, so now let's take an example and try to understand that how the AND and OR operator actually works. So for that I have written this code here. Okay, so now let's try to analyze the output here, how the output is coming and what will be the output. Okay, there are two printf statements here. Let's try to analyze them. So for that we need to make some blocks here first. A, B, C, D, and here it is X and here it is Y. Okay, now here A equal to 3, that means we are writing, okay, A, B, C, D, X and Y. Okay, so here it is 3, here it is 4. Okay, here C is 3 and D is 4. So 3, 4, and then X and Y would be empty. Okay, now here A equal to 5. A equal to 5. This is an assignment operator and it is true because 5 is a non-zero element. Okay, as I have said. So obviously A will be 5, and as it is logically true, we have to go to the next section, which is B equal to 7. So of another assignment operator, so B equal to 7, as 7 is also a non-zero element and which is true. That means true and true, which is X would be 1. Correct? That's why here we have to put X equal to 1. Here also C equal to 5, which is true. So C is going to change as 5, but as it is a OR operator here, okay, we won't be going to this section. Okay, so the output would definitely be 1. Clear? Now when you will be printing out this statement, then the output would be like 5 7 5 4 1 1. This is the output. Clear? Now in the next section, printf X equal to A equal 6. Now A equal to 5, A equal 6 is not going to be true. That means this is false. then we won't be going to this section. Okay, by default x will be obviously x will be 0 due to this false. Okay, now c equals 6, c is obviously 5, so it is not going to be true, so obviously it is false. That's why we would be heading to this one. So d equal to 10. Finally the d value is changing to 10, and this is true obviously, that's why y will be 1. Clear? Now the print, after the printf statement, what will happen that here I have written pf, the short form of printf. Okay, I hope you will understand because it's less space, that's why I have written like this. Okay, so here it will be like 5 7 5 10 0 1. So this is the output. Okay, so in this way we can analyze, we can break down the things, and we can have a solid output. If you don't know this kind of truth table concept which I have shared, okay, actually truth table is in electronics, means modern physics topic, but this logic, this part, this kind of logics which I have shown here, this is new, I guess, for you guys. You haven't thought about truth table in this way. So I think that this concept will be very much useful when you will be solving this kind of problems, that what to skip, when to skip, where to skip. That's the basic thing. Okay, so that's why I think that you need to understand this, and you need to look into it very carefully. Okay, so that you would not done any mistake in your competitive exams like GATE or software company written exams and all. Okay, so yeah, that's it. This is the end of the logical operator, but definitely I would show you in the laptop also that either what I have shown you guys, it is correct or not. Okay, and then we will continue with the rest of the operators. Now let's go to laptop. So here this is the code, and let's run it. So you can see that the output 575411 and then 57511001 as the way I have written. For your confirmation, I have run this code, otherwise I know that it's correct obviously. The logic would be same. So yeah, this is the end of the logical operator. Okay, so now let's talk about the bitwise operator. Now there are various bitwise operators. For example, bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, then left shift, then right shift. Okay, these two actually they are bitwise operators, but in my playlist I have made them separate, which is shifting operator. They also called as shifting operator. It's not my creation, by the way, but I am taking all these two operators separately. Okay, we will talk about them, especially these and these. We will talk about the bitwise NOT operator later, not now. Okay, why later? That thing also you will understand. Don't worry. Let's try to understand these three first. Okay, so we have talked about AND and on gate. Okay, AND and OR gate already. We haven't talked about the XOR gate, so in this video we will also talk about XOR gate also. Don't worry. Now let's start by bitwise OR. Here bitwise OR means, for example, if I take integer a equal to 12 and integer b equal to 15, for example. Okay, not let 15, it's 10, for example. Okay, now we have to do bitwise AND, bitwise OR. So we will write like, for example, integer c equal to a vertical bar b. Only single vertical bar would be used, only single. Now how these calculations would be done, that is very important to know. Okay, so before that we need to understand that the binary number system. If you don't know anything of binary number system, then let me know in the comment section. If you want me to make a playlist on it, I will definitely make a playlist on it. That's not a problem. But in short, if I say the binary of A is 1100, the binary of B is 1010, तो यू माइट हैव अ क्वेश्चन दैट भैया हम लोगों को तो मतलब डिवाइडेड बाय 2 करो फिर रिमाइंडर निकालो, बहुत सारा झमेला हो जाता है, आप ऐसे कैसे बोल दिया, रट्टा मार रहे हो क्या आप? नहीं भाई, रट्टा नहीं मारा है, बिल्कुल भी रट्टा नहीं मारा है, रट्टा नहीं मारना है हमें, वी आर इंजीनियर्स ब्रो। सो हम लोगों को रट्टा नहीं मारना है सब कुछ, ठीक है, हम लोगों को लॉजिक समझना है और टेक्निक सीखना है, ठीक है, दैट्स आवर वर्क एक्चुअली, या टू डू द थिंग्स इन ए स्मार्टर वे, इजंट इट? तो इसके लिए हम लोग को जानना पड़ेगा कि नंबर सिस्टम होता क्या है। नंबर सिस्टम दो तरह के होते हैं, एक होता है वेटेड नंबर सिस्टम, एक होता है नॉन वेटेड नंबर सिस्टम, ठीक है। अभी ये क्या होता है नॉन वेटेड, वेटेड क्या होता है वो मैं इतना डीप में नहीं जा रहा, इतना समझ लो कि वेटेड नंबर सिस्टम के अंदर ही आता है हमारा डेसिमल, ऑक्टल, बाइनरी, हेक्साडेसिमल एंड सो ऑन। ये सारे नंबर सिस्टम डेसिमल नंबर सिस्टम्स के अंदर ही आते हैं, ठीक है, सॉरी वेटेड नंबर सिस्टम के अंदर ही आते हैं। डेसिमल नंबर सिस्टम में क्या होता है ये तुम लोगों को जानना मतलब समझना पड़ेगा, उससे पहले तुम लोग बाइनरी समझो। डेसिमल में क्या होता है तुम भैया हम लोगों को तो पता ही होता है कि 0 से 9 होते हैं 10 डिजिट, इसीलिए 10 डिजिट होता है, इसलिए इसका बेस होता है 10। बाइनरी में सिर्फ 0 और 1 ही होता है, इसलिए इसका बेस होता है 2। मतलब बेस मतलब क्या होता है कि कितना सारा डिजिट्स इसमें यूज हो रहा है, ठीक है। अभी हेक्साडेसिमल का पकड़ लो तो उसमें क्या होता है 0 1 2 डॉट 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 9 तक तो होता है, फिर A B C D E F, मतलब हेक्साडेसिमल मतलब 16, सो 0 से 15 तक होगा, तो 0 से 9 तक हम लोग बना लिया, ये हो गया 10, ठीक है, 10 डिजिट्स यहाँ पे हो गए। अभी दिस रिप्रेजेंट्स 10, दिस रिप्रेजेंट्स 11, दिस रिप्रेजेंट्स 12, दिस रिप्रेजेंट्स 13, दिस रिप्रेजेंट्स 14 एंड दिस रिप्रेजेंट्स 15, ऐसे करके 0 से 15 तक हम लोग हिसाब कर रहे हैं, ठीक है। अभी वो भी चक्कर नहीं है, हम लोग को ये समझना है कि डेसिमल नंबर सिस्टम में काम आखिर होता क्या है। पकड़ लो अगर मैं बोलूं कि 125 125, हाउ कैन वी राइट इट? ऑब्वियसली वी कैन राइट इट लाइक 100 प्लस 20 प्लस 5, क्लियर। लेकिन अगर मैं ये बोलूं कि 1 इंटू 10 स्क्वायर प्लस 2 इंटू 10 टू द पावर 1 प्लस 5 इंटू 10 टू द पावर 0, तुम लोग गलत बोल पाओगे क्या? नहीं बोल पाओगे, दिस इज करेक्ट। तो ये देखो कि ये वाला जो डिजिट होता है, पहला जो डिजिट होता है, इसका वेटेज कितने का होता है? 10 टू द पावर 0 का होता है, इसका 10 टू द पावर 1 का, यहां पे आएंगे तो 10 टू द पावर 2, मतलब हर एक डिजिट का अलग अलग वेटेज होता है, ठीक है। हर एक जो फॉर्मेट होता है, जो पहला वाला स्थान है उसका एक है, दूसरा वाला स्थान है उसका एक है, तीसरा वाला स्थान है उसका एक और है, ठीक है। उसी तरह से ये बाइनरी, डेसिमल, ये सारे वेटेड नंबर सिस्टम्स है, इसीलिए सारे नंबर सिस्टम्स में हर एक जो बीट होता है, हर एक जो मतलब पार्ट होता है, उसका डिजिट होता है, उसका जो स्थान होता है उसका अलग अलग वेटेज है। जैसे कि बाइनरी में क्या होता है 2 टू द पावर 0 होगा पहले का, उसके वाला होगा 2 टू द पावर 1। अभी ये 2 टू द पावर, ये 10 टू द पावर, क्यों? क्योंकि यहाँ का बेस 10 है, डेसिमल का बेस 10 है, यहाँ का बेस 2 है। आप किसी भी वेटेड नंबर सिस्टम का पकड़ लो, बेस टू द पावर पोजीशन, पोजीशन स्टार्ट फ्रॉम ऑब्वियसली 0, बेस टू द पावर पोजीशन, यही होता है वेटेज, ठीक है। पोजीशन मस्ट बी स्टार्ट फ्रॉम 0 ऑब्वियसली, ओके। सो यहाँ पे 2 टू द पावर 0, फिर 2 टू द पावर 1, फिर 2 टू द पावर 2, फिर 2 टू द पावर 3, फिर 2 टू द पावर 4, फिर 2 टू द पावर 5, तो ऐसे करते करते इंक्रीज होता है। अगर मैं डायरेक्टली लिखूं तो 1 2 4 8 16 32 64 128 256, ओके 256, ऐसे होता है। अभी पकड़ लो मेरे को कितना चाहिए? 12 चाहिए, तो 8 4 12, तो खत्म, 1100, 10 चाहिए ना अपन को, सो 1 8 2 10 खत्म, 6 चाहिए अपन को 110। तो भैया ये सारे डिजिट्स क्या होते हैं? इनमें सब 0 भरे होते हैं, ठीक है। अभी कितना 0 होगा? दिस डिपेंड्स ऑन द मींस हाउ मेनी बिट्स, ओके 8 बिट 16 बिट 32 बिट। आपका ऑपरेटिंग सिस्टम कितने का है? 64 बिट, तो यहाँ पे 4 डिजिट होगा और 60 जीरो होंगे, टोटल 60 जीरोस। 32 बिट ऑपरेटिंग सिस्टम है, यहाँ पे पकड़ लोगे यहाँ पे 3 है तो 32 बिट में कितना आएगा और 29 जीरोस। तो इन दिस वे कंप्यूटर में डेटा स्टोर होता है, क्योंकि कंप्यूटर में बाइनरी यूज होता है। ये मैं पहले ही बता दूं, क्योंकि सामने वाले लेक्चर्स में आपको बहुत अच्छे से ये जानना पड़ेगा कि क्या क्या कैसे कैसे होता है, ठीक है। तो वैसा कुछ है। जब हम लोग दूसरा प्लेलिस्ट में शुरू करूंगा, जब कंपैरेटिव कोडिंग का प्लेलिस्ट जब आएगा, इसके बाद डेटा स्ट्रक्चर्स आएगा, फिर धीरे धीरे आता रहेगा। तब जब बिट मैनिपुलेशन में हम लोग जाएंगे, जो कंपैरेटिव कोडिंग का बहुत ही सही पार्ट है, अगर आपको बिट मैनिपुलेशन नहीं आता तो शायद यू विल बी लैगिंग बिहाइंड, तो तब जाके भी ये वाले कॉन्सेप्ट बहुत काम आएंगे। bitwise operators would be used there as well, so you definitely need to understand all these things, so be careful, बहुत ही attentive रहिए इस पार्ट में मेनली, क्योंकि आगे जाके भी बहुत काम आएगा। शायद अभी काम ना आए कुछ ज्यादा, लेकिन सामने जाके बहुत काम आएगा, ये बहुत इंपॉर्टेंट है, ठीक है। तो वैसा कुछ होता है। अगर तुम लोग को पकड़ लो कितना दो 20, तो 20 का क्या होगा 16 और 4 20, फिर 21 चाहिए तो एक और एक लगा दो, तो 10101 is 21। In this way we can write the binary numbers of decimal numbers. So अभी मैंने क्या लिखा, जो bitwise और तुम लोगों को दिखा रहा था, तो वहां से निकल गया था मैं। तो ये वाला जो पार्ट है इसको हम लोग नीचे भी लिखते हैं, फिर बात करते हैं, ठीक है। a इक्वल टू 12 एंड a इक्वल टू 12 एंड एंड b इक्वल टू 10। अभी इसका क्या होगा 1100, इसका क्या होगा 1010, करेक्ट। बेस 2 यहाँ पे एक्चुअली हम लोग को बेस 10 लिखना चाहिए, लेकिन हम लोग लिखते नहीं, क्योंकि यूजुअली हम लोग डेसिमली यूज करते हैं, तो जनरली लिखते नहीं ना। अभी तुम 5 को +5 तो ना लिखोगे, बाय डिफॉल्ट इट्स प्लस ना, तो दैट्स व्हाई। नाउ अभी ये तो लिख लिया। अगर हम लोग लिखा कि c इक्वल टू a bitwise और b, ओके, तो क्या होगा, कैसे कैलकुलेशन होगा 1 1 0 0 1 0 1 0, ओके। अभी अपन को क्या करना है, अपन को बिटवाइज डिवाइड करना है इनको, ठीक है। उसके बाद जो बिटवाइज जो बिट्स होते हैं उनके बीच में और ऑपरेशन करना है, ठीक है। तो ये होगा बिटवाइज और, अपन को आंसर लिखना है। तो 0 0 का बिटवाइज और कितना होगा 0 होगा, 0 0 0 1 ऑब्वियसली 1 1 0 1 1 1 ऑब्वियसली व्हाट 1, दैट्स इट। सो क्या आ गया अपन का, दिस इज द आउटपुट। अभी आउटपुट कितने का है, ठीक है, ये अपन को जानना पड़ेगा। सो 1 2 4 8 8 4 12 2 14, दैट मींस c इक्वल टू 14, दिस इज द आंसर। चेक कर लो, कंपाइलर में लिख लो, ठीक है, चेक कर लेना। अगर कोई गलती निकल जाए तो कमेंट में बता देना, अगर सही निकल जाए फिर भी बोल देना कि भैया चेक किया था, ठीक है, आई विल बी हैप्पी, ठीक है। अभी ये गया बिटवाइज और, अभी पकड़ लो कि बिटवाइज एंड। बिटवाइज एंड, अभी बिटवाइज एंड में क्या होगा, वहां पे डबल एम्परसेंड सिंबल था, यहाँ पे सिंगल एम्परसेंड सिंबल होगा, दैट्स इट। फिर से बोलते हैं इंटीजर a इक्वल टू 26 एंड b इक्वल टू 34 फॉर एग्जाम्पल, ओके। अभी इनका बाइनरी कैसे निकाले, अभी तुम लोग क्या करोगे, ऐसे लिख लेना 1 2 4 8 16 32, बस दैट्स इट, 32 हो जाएगा, ठीक है। अभी 34 का बाइनरी कितना होगा 32 1 0 0 और 2 लगा दो, बस बात खत्म, दिस इज। उसके बाद 26 का कितना आएगा, ऑब्वियसली यहाँ पे आएगा 0, फिर यहाँ पे आएगा 16 16 और 8 24 24 और 2 26, बस दैट्स इट। अभी अपन को बिटवाइज एंड करना है ना, तो बिटवाइज डिवाइड करो सबको, फिर बिटवाइज एंड डालो, आउटपुट कितने का आएगा, यहाँ पे 0 0 0 1 0 0 0 0, that means the answer is 2. That means if I write integer c equal to a bitwise and b, that means c will be having the value only 2. That's it. Correct? बस इतना ही है यार, और कुछ नहीं है, तुम लोग को ऐसे कैलकुलेट करना पड़ेगा, ठीक है। नाउ लेट्स टॉक अबाउट द जोर गेट, बिटवाइज जोर। बिटवाइज जोर के पहले तुम लोग को ये समझना पड़ेगा कि जोर एक्चुअली होता क्या है, ठीक है। इसको गेट को हम लोग ऐसे लिखते हैं, ए बी वाई, वाई इक्वल टू ए बी पर प्लस ए बार बी, करेक्ट। अभी इसका जो सर्किट डायग्राम है उसमें हम लोग नहीं जाते, ये दिस इज द पार्ट ऑफ द डिजिटल इलेक्ट्रॉनिक्स, अपन को क्या है, अपन को ट्रूथ टेबल से मतलब है, तो अपन ट्रूथ टेबल निकालेंगे ए बी एंड वाई, 0 0 0 1 1 0 1 1। अभी 0, ओ सॉरी सॉरी सॉरी, अभी कैसे निकलेगा, अभी इसका देखेंगे, ठीक है, 0 0 है तो यहाँ पे तो आएगा 0, यहाँ पे आएगा 1 और यहाँ पे आएगा 1, यहाँ पे आएगा 0, दैट मीन्स 0, ठीक है। अभी दूसरा वाला पकड़ते हैं तो क्या आएगा, 0 और 1 है तो 0 0 प्लस 1 1, दैट मीन्स आएगा 1, ठीक है। अभी तीसरा वाला पकड़ते हैं 1 एंड 0, तो कितने का आएगा, फिर आएगा 1 1 प्लस 0 0, दैट मीन्स आएगा 1। अभी फिर से चौथा का पकड़ते हैं तो आएगा 1.0 प्लस 0.1, अल्टीमेटली आएगा 0, दैट मीन्स यहाँ पे आ रहा है कि 0 1 1 0। अभी एक चीज नोटिस करो, यहाँ पे डिफरेंट इनपुट्स हैं, ठीक है, ए और बी दो डिफरेंट इनपुट्स हैं, ठीक है, एक है 0 एक है 1, एक है 1 एक है 0, तभी आ रहा है आउटपुट 1। लेकिन अगर हम लोग सेम इनपुट है ए और बी का, तब आया आउटपुट 0। What does it mean? It means that if you have that means XOR gate is an inequality checker. XOR gate is an inequality checker. It checks either the input bits are or either the inputs are equal or not. If they are equal, then fine. If they are not equal, then obviously 0. इसका जो उल्टा है XNOR गेट, ठीक है, XNOR गेट जो होता है वो उसका उल्टा होता है, वो होता है इस तरह का, यहाँ पर एक डॉट होता है बीच में, ठीक है, मैं दूसरे कलर से बनाता हूं, ठीक है, फिर यहाँ पे आएगा आउटपुट ए बी एंड वाई, तो यहाँ पे पूरा उल्टा हो जाता है, दिस इज इक्वल टू ए बी प्लस ए बार बी बार। इसको हम लोग इस तरह से भी लिख सकते हैं, ए बी बार प्लस ए बार बी होल बार, तो इसको हम लोग यहाँ पे डाल सकते हैं, ला सकते हैं बाय यूजिंग द डिजिटल इलेक्ट्रॉनिक्स कॉन्सेप्ट, ओके। वो अलग चीज है, ठीक है, उसको छोड़ो, तो इसको लिख सकते हैं। तो इसका जब ट्रूथ टेबल बनाएंगे तो क्या आएगा, ए बी एंड वाई, इसका आएगा कुछ इस तरह से 0 0 0 1 1 0 1 1, यहाँ पे आएगा 1 0 0 1। यहाँ पे क्या होता है कि अगर इनपुट सेम हो तो आउटपुट आता है 1, देखो, और इनपुट्स अगर अलग हो तो आउटपुट्स आते हैं 0, दैट मीन्स इट इज द इक्विलिटी चेकर, दिस इज द इक्विलिटी चेकर, दैट्स इट। तो ये वाला सी में उतना है नहीं, लेकिन हम लोग फिर भी उसको यूज कर सकते हैं। बाय द वे बिटवाइज XOR को हम लोग इस तरह से लिखते हैं, दिस इज द वे वी यूज टू राइट इट। अगर बिटवाइज नॉर XNOR निकालना तो हम लोग क्या करेंगे, एक नॉट बिठा देंगे, लॉजिकल नॉट बिठा देंगे, फिर लिखेंगे ए XOR बी, बस आ जाएगा XNOR, ठीक है। तो दैट्स द इट्स जस्ट रिवर्सिंग टू ईच अदर, ओके, रिवर्सल टू ईच अदर, सो दैट्स ओके। नाउ इसका यूज कैसे करेंगे, पकड़ लो। Now let's take a equal to 12 and b equal to 6 for example। इसका आएगा कितना, 1 1 0 0, इसका क्या आएगा 0 1 1 0। तो बिटवाइज XOR करेंगे तो कैसे करेंगे, तो 1 1 0 0 0 1 1 0, उसका क्या करेंगे, बिटवाइज XOR, सो दिस इज द ऑपरेशन। तो बिटवाइज अलग करेंगे, ठीक है, तो 0 0 आएगा 0 0 1 आएगा 1 0 1, दैट मीन्स 1 0 1 0 विच इज 10। तो अगर हम लोग c इक्वल टू a बिटवाइज XOR b करेंगे तो c का वैल्यू आएगा 10, दैट्स इट, दैट इज बिटवाइज XOR ऑपरेटर, ओके। नाउ let's talk about the left shift and right shift, and after that we will give some examples in VS Code, and these examples I will run and I will show you guys that everything is okay, okay. Now let's talk about the shifting operator. There are two shifting operators. The first one is left shift, another one is right shift. left shift has been denoted by double less than, and right shift has been denoted by double greater than. Okay, now how they actually going to work? Okay, so for example, if I write integer a equal to 15, and then if I write a equal to a double left shift 2, okay, I want to do this. Obviously, okay, for example, if I write here b equal to integer b equal to a double left shift 2, then obviously the answer will be like 60. So how I can directly say that it's 60, that also needs to know. But before that, you need to understand that what exactly left shift operator does actually. Okay, so for this we need to convert it into binary. So a equal to 15, which means 1111 in binary. Now let's write it here, 1111. Left shift means every bit would be shifted into the left direction. That means this one would be shifted to here, this one would be shifted to here, this one would be shifted to here, and this one would be shifted to here. After that, what will happen, that 1111 and this two, this place and this place, these two would be empty. We have to put here zeros, so this would be the result. Okay, which means if I say 1 2 4 8 16 32, 32 plus 16 is 48, 48 plus 4 is 52, then 60. So 60 would be the answer. So how this is working and what is the shortcut key, we need to understand that. So if any number is a has been left shifted by x bits, okay, here 2 means how many bits we are going to left shift. Okay, how many bits we are going to left shift. And if I do the left shift by x bits, then the output would be a into 2 to the power x. This would be the output. A double left shift x means this would be the output. So here a is 15, obviously a is 15 and x is 2, that means 15 into 2 to the power 2, which means 15 into 4, which means 60. This is the shortcut formula to find the left shift. Okay, so in this way we can find the left shift. Now let's talk about the right shift. Right shift, for example, a equal to 48. Okay, now right shift means a double slash 2, isn't it? So b equal to a double slash 2. So what would be b equal to, obviously a right shift 2, which means so 48 right shift 2, that means 4 12 would be the answer. So how 48 का बाइनरी कितना होगा, तो 1 2 4 8 16 32, 64 का तो कोई मतलब नहीं है, तो 1 1 0 0 0 0, this is the binary. This is the binary of 48. So when we will be doing the right shift, so we need to write this 1 1 0 0 0 0. We need to put a just a bar here and right shift. So right shifting is happening, isn't it? So 1 1 0 0 and this 0 0 would be coming. So there are two empty places here, we have to put 0 0. So this is 2. Now this would be the answer, which is 1 2 4 8 8 and 4 is 12. So 12 is the answer. That's it. This is the right shift. So these are very simple. Okay, for left shift you need to do a into 2 to the power x, and here a divided by 2 to the power x for left shift and for right shift. These are the shortcut formulas to find out the result, and this is the way. So this is shifting operator also. When you will be using left shift operator using assignment operator, so you can write like this also: a double left shift 2, a left shift 2, a left shift right shift 2. We can write like this also. It's like a plus equal to 2. What is it? It means that a equal to a plus 2, isn't it? So when we're writing like a left shift equal to 2, it means a equal to a left shift 2, correct? So yeah, so here you can see that left shift of 15 by 2 bits is 60, and 48 right shift of 48 by 2 bits is 12, as I have said. Okay, so here in this code, a equal to 12, b equal to 10, as I have shown you in the iPad. So here this is the output. Let's check. So here 14, as I have showed, and a equal to 26 and b equal to 34, and here it is bitwise and okay, and here you can see the output is 2. Okay, so this is the examples which I have shown and I am showing you here. And another one is bitwise XOR, which is a equal to 12 and b equal to 6, and here it is bitwise XOR. So here you can see that 10, as I have shown you guys. Okay, so this is the thing. Left shift and right shift also I have shown you guys. So let's start the conditional operator. Okay, conditional operator actually is also a ternary operator because it use more than one statements, more than one part and more than one symbols as well. Okay, it's a ternary operator. So both of them together are called conditional operator. How? What is the syntax actually? The syntax of conditional operator is, here there is a expression or condition, and then there would be a interrogative sign, and then statement 1, and then there would be a colon, and then statement 2, and then there would be semicolon. Now if the expression of the condition is true, then statement 1 would be executed, and if the expression of the condition get false, then the statement 2 would be executed. This is called conditional operator. The condition is true, then one statement would be executed. If the condition is false, statement 2 would be executed. Now let's go to laptop and check what exactly it is. For example, integer a equal to 20 and b equal to 15. Okay, now a greater than b. Okay, printf %d is so here a greater than b is a conditional statement. It's a relational statement, isn't it? So as the relational operator is used here, that's why it is relational statement, by the way. So a greater than b, these expression, if it is true, then a is greater than b would be printed out, and if it is not true, okay, then obviously b greater than a would be printed out. So let's check. Obviously 20 is greater than 15 has been printed out, isn't it? Now let's take another example. Printf, yes, for example I'm just writing printf yes, and here it is printf no. So let's see. Yes, A is greater than B. It's true. So that's it. Okay. So this is all about conditional operator. Okay. Now let's talk about increment and decrement operator. Okay. So there are two types of increment and decrement over. The first one is prefix. Another one is postfix. Okay. Prefix means, okay, first of all, the increment and decrement operator are denoted by plus plus and decrement is denoted by minus minus. Okay. Now for example, if I write a equal to 10 and after that if I write a plus plus or a minus minus, this is called postfix. Postfix, increment or decrement. Okay. And if I write plus plus a or minus minus a, okay, then it is called prefix. Prefix, increment or decrement, whatever it is, depending on the plus plus and minus minus. Okay. Now why it is called postfix, why it is called prefix? Post means baad mein, after. As the plus plus or minus minus has written after this variable, that's why it is called postfix, and here it is written before the variable, that's why it is called prefix. Correct? Now how it is actually working, this is very little bit complicated for the beginners, but it's very easy. Okay, don't worry. Okay, if I write a equal to 10 and after that a plus plus means, okay, a plus plus means there are two lines inside this, printf %d a and then a equal to a plus 1. If I write plus plus a, then a equal to a plus 1 and then printf %d a. Okay, so this is the thing. A plus plus means the increment would be done later, and plus plus a means increment would be done earlier, after and before the printing. Okay, so that's it. This is very simple. Let's take some example and let's understand that what exactly happening. Okay. Then minus minus. So what is the output actually is going to happen? Okay, we need to understand that. So a equal to 5, that means the output would be 5 here. Plus plus means what? It would be printed first and then it would be incremented, isn't it? So it is 6 and 5 would be printed out and then it would be incremented. So it's like I can say, okay, I can say printf %d comma a, okay, and then a equal to a plus 1. Okay, I can say like this, and as it is a plus plus, that means I can say the opposite one. I mean okay, I can say like this, that this line would be, so this means these two lines and this means these two lines. It's very easy to remember. Obviously it's a lengthy process. Every time you need to break them into two, and just for now, as you are a beginner, you can use this one. When you will be an expert one, then you can directly say like this, like me. Okay, so you can directly do that, but for now I would recommend you to use this process as you are a completely beginner in C language. Okay, so a equal to 5, obviously then it is printed out, and then a equal to a plus 1, that means a value is a value is 6 now. So obviously here it is a equal to a plus 1, then obviously it is 7. So here actually the printing value is 7, this line. Okay, then 7, that means this is 6, then obviously this is 6, but it is 5, then obviously it is 5, and then it is 5, that means 4, that means obviously it is 3, and then it is 3, and then it is 4, and then it is 3. Okay, so this is the thing. Yeah, let's check it out. So yeah, 5 5 7, okay, 5 5 7, and then 6 6 5, then 3 3 4 3, everything is correct. Okay, which I have said, everything is correct. Okay, so this is the way you can use the increment and decrement operator. So now we have done arithmetic operator, assignment operator, logical operator, bitwise operator, shifting operator, relational operator, conditional operator, increment and decrement operator, and right now this is Sizeof operator, and another one which I forgot to mention, which is comma operator. So comma operator is not that much important, but I will give an example and you will understand. Now let's talk about the Sizeof operator. Okay, so Sizeof operator. Okay, so before starting with the Sizeof operator, we need to understand what is exactly size. So as we all know that, and if you don't know, then obviously you definitely do watch this very minutely. Okay, integer a equal to 5, for example this. Okay, and another one is integer a. There are two differences here. Okay, or both of them are declaration. So when any variable has been declared or anything has been declared in C, in the memory is like this. Okay, memory is what? The size of the RAM actually. Okay, so in memory there are various memory segments, which is stack, heap, coding segment, then global variable, static variable. There are different things. Okay, so we are talking about only the stack segment because it's all about static memory location. So I am not going into a deeper section. Just for now, you need to understand that memory is like this. Is simple. It's just like this. You can understand. Okay, it's just like a there are many blocks. Okay, who are simultaneously connected to each other in a contiguous memory location. Okay, memory location starts from, for example, 0 to, for example, 100. It's not defined anything, but I would start by, for example, 100. Okay, so this is 100, this is 101, 102, 103, okay, 104, 105, 106, 107, it is 108. Okay, so size means all these this single room is called a 1 byte. 1 byte. Okay, 1 byte means 8 bit. Okay, you all know that 1 byte obviously. So 1 byte. So size means what? Size means the number of bytes it takes space in the memory. So integer takes 4 bytes. That means is 4 bytes, isn't it? For example, this is an integer which is a. So when you declare any variable like this, it took some space in the memory, that is called the size. Okay, and when it is a equal to 5, then what will happen? These 4 bytes are going to be like this. I'm just showing an example. Okay, so this is 4 bytes, and 4 bytes is going to divide into 32 bits like this. And then as we have declared initialized it by 5 means what? 101. That means 101, and then okay, so 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0, all these are will be zeros. Okay, only this is 1 and this is 1, but as it is 5. Okay, in this way actually the data has been stored into our memory. It's very important, very conceptual thing, so remember it. Okay, so this is the way actually everything stores in memory. So size means what? Size means the size, number of bytes actually, which takes any variable, takes by which is taken by variable while declaring in the program. दैट्स इट, मतलब जितना जगह वो लेगा उसको उसका साइज बोलेंगे. अभी ये साइज ऑफ ऑपरेटर व्हाट डज एक्चुअली इट डज, it returns size of, for example, if you write size of int a, then size of a, or we can write like this, size of, we can use here also size of int, or I can say okay, no, yeah, so we can write this and it will return 4, as in our computer 64-bit operating system or 32-bit operating, whatever it is, 32-bit or 64-bit, it would return 4. In 16-bit it would return 2 only. Okay, in the chart, in the data type video which I have talked about. Okay, so in 16-bit operating system it's 2, but in our operating systems it's 4. You can check it out by yourself. Let me show you. So this is the mainly, this is the size of operator, and this use actually very important when we will be talking about the dynamic memory allocation. Okay, the size of operator uses in many places, but in dynamic memory allocation we are going to talk about that. So for example, integer a equal to 166, for example, and if I write printf %d is the size, then comma, and size of, okay, a, so you can see 4 is the size. Now if I do not use this line and if I write only int, then you can see 4 is the size. If I write float, obviously you can see 4 is the size. Okay, now if I use double, so you can see 8 is the size. If I use long double, then 12 is the size. So in this way we can use the size of operator. And this is the ending part of the video. Operator, okay, different types of operator we have talked about. In the next video we will be talking about type conversion and the precedence and LCVT chart of operators, which are very important. I'm not discussing in this video because this video has been a long video, I guess. So let's just break here, and in the next part we will be talking about these two very important topic, and then we will be going to control statements. So thank you so much for watching this video. If you found this video useful, please do hit the like button and let me know in the comment section if any kind of doubt is there, and do support the channel. If you haven't subscribed it, please hit the subscribe button and press the bell icon so that every video could be reached you through notification. So this much for today. See you on the next video, and keep learning, keep growing guys, keep coding. So that's it. Yeah.